section information screens provides the design methods you'd like to use. We can force a reinforced design, a primary disclaimer. In the NCMA, we can say use vertical delta force. That's a friction between the soil and the back of the blocks, or include the vertical force as resistance. The NCMA defaults to ignoring the vertical force. You can override it in this program. You can override it in the NCMA SR1 program. We'll leave it like that. Our design methods, NCMA, AASHTO 2002. This is the highway methods are the AASHTO. These are both working stress designs, work on a factor safety basis, what we mentioned before when we talked about the factors of safety. The load factor reduction, work on load factors and reduction factors instead of factors of safety. Most of the designs for commercial projects will be done following the NCMA method. If we look at force of reinforced design, if we go back and we have the Cornerstone 100 stratogrid reinforcing, we do a wall height of say 3 foot high. We've got good soils behind the wall. Let's see what happens. It still makes it reinforced, but if I were to drop my let's go with a bigger unit block. Let's go with a Cornerstone 200 unit, a stratogrid reinforcing. We'll throw 500 in there, reinforced. That comes out as a gravity wall. Whether you choose gravity design or reinforced design, it will always check gravity first. And if it'll work as a gravity wall, it will design it as a gravity. There we go. As a gravity, even 5 foot high. The Cornerstone 200 has a factor of safety overturning 1.6, sliding 1.5. So yes, it is stable as a gravity wall. But it could be that we want to force a piece of geogrid in it, so we'll click that checkbox. Now we do a reinforced design. It will throw grid in the wall. Just a way to override the program calculations. We can update it. You know, there's a good design. Print preliminary disclaimer. When we do an analysis, then we go to print our results. Print design, we'll just print a short design. If we look at the bottom of the page, there's a disclaimer on it. Calculations of quantities are for preliminary use only, not to be used for final design or construction. This is great for preliminaries you're putting out. People aren't going to design with it. If you're the engineer, you're the designer, you want to put a stamp on it, we can go back to section information. We can uncheck that checkbox. We can do our design again. We look at our print design, and you'll see the disclaimer is now gone. So that's your option to turn that disclaimer on or off for that checkbox. We can also go back into preferences, and there's a checkbox right here, show preliminary design. If you uncheck that, the default in the program will come up as unchecked. So you don't have to click that every time. Print a trial wedge analysis. A little beyond what we're talking about now, but if we have a slope angle of 15 degrees that goes back for 2 feet, that's a broken back analysis. You can see our failure plane here is beyond it. That's going to force the program into a trial wedge design. An infinite slope calculation would be more conservative. This is more accurate. What this does is that it prints those results to a text file. You can open that file and look at it and see the trial wedge results. I think if we look at the AASHTO methods, the NCMA checkbox here goes away. We still have force reinforced design, 0 delta for single depth walls. AASHTO really doesn't give you a choice on including wall friction or not. Their wall friction is delta angles equal to the slope angle. Delta equals beta. So if you have a wall with a slope, it's going to have a delta, and you do have the choice here of turning that on or off within AASHTO. Same print disclaimer, same print there. Back to NCMA, a few dialogues up here that tell what the program is doing.